Hello everyone. My name is Guang and it's Corey. We are leading the backend development for our fall detection system. Throughout this project, our roles is in design the system architecture and ensure some smooth data pipeline from IoT core to prediction. So the first challenge is the fall detection is how critical is it, and the speed and the accuracy is paramount. And initially, the raw data is hard to process due to its raw format, and we face it with the challenges to deploy in the system in the cloud with the right combination of tools. And why this matters. So the hurdles were important to overcome because the system could potentially save lives, be delivery quick, and freezes alerts when the fault occurs. To tackle the challenge, we start mapping out the entire system, allow us to see the big picture and focus on the detail. So first of all, we need to design a system architecture, and then we try to make a pre-processing function to translate from the raw data to imaging data, and then pass through the image data to the model, and we get the prediction. So after transform the data, I made API that allows the system to communicate with uh, to device communicate with the system. So the improvement that faster get enable to faster respond and open the door for future development, especially in the health monitor application. And as you can see, first of all, have an upload CV file that we put the raw data that we run the prediction, and then we upload the table in the database to get update, and the table is linked directly to the GUI, so the user can see that. And what we get so far is that we achieve a model with accuracy of 92%, and the system respond in 6 seconds. It's critical to an application where the time make all the difference. We also complete the major milestone like making processing function, building prediction capability, and developing a full-scale API. And that allow us to create a system not only perform well, but also adapted and scaled it to the several real-world application. And now Corey will make a presentation about the light data pipeline.
Thanks, Kwang. So for all of these tools to be deployed in industry, there has to be a cloud architecture in place so that the radar devices can be deployed across multiple different locations. And this architecture needs to be cost effective so that it's viable. It needs to be scalable so that it can be added when new locations are added to the roster, and it needs to be easy to update. So if the model changes or something else changes that's improved, we need to be able to update all the devices and the architecture in one easy way. And so far, we've built a few different architectures and trialed a few. Our original architecture was really good, but too expensive, so not cost effective. Our second architecture, which we're beginning to work on now, uses Elasticache, and that has its benefits, but it's still more expensive than our third model, which we're going to begin deploying soon, which is based largely just around Lambda functions in AWS and then doing some pre-processing on the radar devices themselves. So this has some issues with updates. It might be a bit harder to update the code on the devices than it would be just to update code in the cloud architecture, but the cost saving that it brings with it is well worth it. So you can see this is the original architecture before we began building and really learning along the way what would work and what wouldn't work. And you might be able to see that as our architecture goes along, it actually gets more simple. So that makes it more cost effective and more efficient and easier to manage and update for the business. So our Elasticache architecture, pretty much the only difference between this and the other architectures is the use of Elasticache to store the radar data coming in on the cloud. So it'll store it for the last X amount of seconds. At the moment, it's 15 seconds for our model, but that can be adapted easily over time. The negative thing about this model is that it costs $16 a month for one device just for Elasticache. So that can be a bit expensive if it can be avoided. And that's what we've avoided with the second model, the third model, which will bypass actually storing data at all in the cloud. And instead, it will just store data, pull data for short periods of time on the Raspberry device itself, and then send that through an API gateway to Lambda functions, which will do all of the heavy lifting that otherwise would have been done with EC2 and with like stand-based storage like time series, DynamoDB, Kinesis, or Elasticache. And so we're going to continue after these models to improve performance and scalability and cost effectiveness of the systems so that they'll be able to be deployed in more varied situations uh, and cheaper so that more people can actually use them, both in hospitals, you know, home care for the elderly, or even personal health monitoring, maybe at home for an elderly or disabled patient. And yeah, that's all. Thank you.